In this video, we're going to be translating the motion of an object into some kinematic curves, a position versus time graph, velocity versus time graph, and acceleration versus time graph. So it can be pretty difficult to take a look at the motion of an object or to read a description and translate it into a graph, but if you break it down into some smaller steps, it'll make it a lot easier and you're going to be a little bit more effective in creating these graphs. So first of all, we have an object moving down a ramp. So we want to identify two things. Which direction is it going, positive or negative, and is it speeding up, slowing down, or going constant velocity? So we're going to say anything going to the right is positive. So we're going to say it's going at positive in the positive direction. And because it's going down the ramp, gravity is going to make it speed up. So then we're going to say it is speeding up. And then on our position versus time graph, because it's in the positive direction, we're going to rise up on the graph. And because it is speeding up, we want to make sure our slope is getting steeper and steeper. Now for the velocity versus time graph, we're just going to assume that it starts at rest. And if it's increasing in the positive direction, it's going to look something like this. And if it has a positive slope on the velocity versus time graph, that means it has a positive rate of change, which is the acceleration. Now, taking a look at the blue portion of the graph, this one is on a flat surface and gravity is no longer affecting it in the same way. So we're going to assume that it's moving at a constant velocity on this flat surface and the positive direction because it's moving to the right as well. Now it already had a velocity at the bottom. It's just maintaining that velocity. So whatever slope that is, you're just going to continue along with that same slope and make that a straight line. And then same thing with this velocity. We're going to maintain this velocity by keeping it a flat line. Now, because there is no change in this velocity, there is no acceleration because the acceleration is the rate that velocity is changing. Now that completes our first one. Now for our second graph, we have an object, or our second scenario, we have a ball moving up the ramp. And if it's moving up the ramp, it's going against gravity. So it's still going in the positive direction, but this one is slowing down. So it's moving forward, but the slope is getting less and less steep. And then for this one, it's a positive velocity, but if it's going slower, that means it's heading towards zero. And then again, when we go from the velocity versus time graph to the acceleration versus time graph, because this is a constant negative slope, that means it has a constant negative acceleration to show that rate of change. Now for the second portion, the ball is going to come back down the ramp, which means it's now going in the negative direction, and now it's going to start to speed up. So for the position versus time graph, we want to go downwards and we want to get steeper and steeper. So we're going to go down and then go steeper and steeper and steeper. And then for the velocity versus time graph, we are already at zero because it momentarily comes to rest at the top of the ramp, but we want to make it go in the negative direction and go farther and farther away from the x-axis because the x-axis is 0 meters per second. So this is speeding up in the negative direction. And this does actually maintain a constant negative slope. So this maintains a constant negative acceleration. Now this is a pretty tricky case because this line is consecutive and so is this one, but the motion is fairly different when you're taking a look at it in real life because this is positive and this is negative. The acceleration is the same because of the slant of the ramp and how it affects the object. Now, how can a negative acceleration send something up and down a ramp? It's pushing downwards in the negative direction the whole entire time. Now, a negative rate of change would slow down something that's going positive, but if something is going negative and you have a negative acceleration, it's going to help it speed up. Now, in our last case, we have three different types of motion. This one is going down in the negative direction because it's going down the slope. It is speeding up. So negative speeding up would be going downwards like this and getting steeper and steeper. And then for the velocity versus time graph, we're going to assume that it starts from rest and then it becomes increasingly more negative as you go. And then because this has a constant negative slope, we have a constant negative acceleration. Now for our blue portion, again, it's on a flat part of the ramp. So we have a constant velocity again, and this is still continuing in the negative direction. So for the position versus time graph, we're going to continue with this same slope. We're just going to make it straight, and then we're going to continue with the same velocity by extending it outwards like this, but because it's a constant negative velocity, it is a flat line below the x-axis. And this has no slope, so we're going to go right here, right on the x-axis for the acceleration versus time graph to show that there is no change in velocity. And then finally, for the third portion, it's going up the ramp, which means it's going to end up slowing down as it continues in the negative direction. So if it continues in the negative direction, it's going to go down, but the slope is going to get flatter and flatter as you go. And then for this one, if it's going in the negative direction and it's slowing down, that means it's heading towards zero, because heading towards zero is decreasing. So although this sort of looks like it's speeding up, it's becoming a smaller and smaller negative value and heading towards zero, which means it's slowing down in the negative direction. And then we have a constant positive slope here. So we have a constant positive acceleration right here. So when taking a look at a diagram or reading a word problem or just watching a video or seeing a lab in real life, when you take a look at the motion of the object, if you break it down into its direction, as in positive or negative, and then identify if it's speeding up, slowing down, or going at constant velocity, it'll make it a lot more simple in translating that motion into graphs. You have to follow some certain rules showing that it's getting steeper if it's speeding up, it's straight if it's at a constant velocity, it's becoming more and more flat if it's slowing down. So you definitely have to familiarize yourself with all those concepts in order to effectively draw those graphs. But I hope that was helpful to you. Thank you for watching and listening.